photodiode. The photodiode is a special type of junction diode made from photosensitive semiconductor used for detecting optical signal. So photodiode is a special type of junction diode which is basically used for detecting optical signal. A photodiode is generally connected in reverse biased. Photodiode is generally connected. Photodiode is generally connected in reverse bias. We know that there are two biasing conditions. One is forward bias and one is reverse biased. Photodiode is always connected in reverse biased. What is the symbol of photodiode? This is the symbol of the photodiode. So this is the connection. The negative terminal of the battery is connected to P side and positive terminal to the N side. What is the current? Current is the microammeter, because under reverse bias condition, only minority charge carriers flows through the junction. Only minority charge carrier flows through the junction, and therefore the current is of very small magnitude of the order of 10 to the power minus 6 ampere. Therefore we have to use the microampere. So this is the VI characteristics. This is the VI characteristics. This VR means reverse bias voltage, IR means reverse current. It is microampere. Have you seen it? The first one is written as dark current. That means if no light falls on the junction, that means it is operated under dark condition. If no light falls on the junction, we get this is the current. This is the current. This current is called reverse saturated current, and this current is reverse saturated current, and this current is only due to flow of minority charge carriers. So this current is reverse saturated current, and it is due to the flow of minority charge carrier through the junction. Now as the intensity of the light falling on the junction gradually increases, the strength of reverse current also gradually increases. You see, I3 is greater than I2, I2 is greater than I1. Here I3, I2, I1 are intensity of incident light. As the intensity of incident light increases, current through the junction increases. Actually, why current through the junction increases? When more intense beam falls on it. Now we want to discuss that. The working of photodiode. When a photodiode is illuminated, when light falls on the junction of a photodiode, when a photodiode is illuminated with light photon of energy h nu greater than the energy gap between valence band and conduction band of the semiconductor, additional number of whole electron pairs are created. Additional number of whole electron pairs are created. I think তোমালোকে already জানা যে কি হয়, solid has two types of energy level. This is the valence band, and this is the conduction band. Valence band is completely filled up. So this is the energy gap between conduction band and valence band. That means when a light falls on the junction of photodiode having energy greater than this energy gap, then what happens? Equal number of whole electron pairs are created. This is because an electron jumps from valence band to the conduction band after absorbing energy of incident photon, thus creating a hole in valence band and a free electron in conduction band. And due to junction field, can you remember in PN junction, an electric field is there directed from N side to P side. So this is the P side, this is the N side. There is an electric field is there at the junction. Due to junction electric field and due to electric field at the junction, and also we make it reverse biased, yes or no? We make it reverse biased. As a result, junction field increases. Due to reverse bias. And due to this, majority charge carrier cannot cross the junction. But when the light falls on this junction, equal number of whole electron pairs are created as the electron jump from valence band to conduction band. And due to junction field, electron get collected to the N side and holes to the P side. When the whole electron pairs are created, due to this electric field, the free electrons are moving towards the N side and newly created holes are moved towards the P side. As a result, the charge carrier increases, minority charge carrier increases, and due to which the reverse current increases. This send a current through the load. As the intensity of radiation increases, more and more whole electron pairs are created, which increases the reverse bias current. So again, I want to repeat it. When a photodiode is illuminated with light energy, having photon h nu greater than the energy gap between conduction band and valence band of that semiconductor, the electron make a jump from valence band to conduction band. As a result, a free electron is created on the conduction band and a hole is created on the valence band. So when the photodiode is illuminated with light photon having energy h nu greater than the energy gap between valence band and conduction band of the semiconductor, additional whole electron pairs are created at the junction. Additional whole electron pairs are created in the junction or near the depletion region. This is called the depletion region. Equal number of whole electron pairs are created in the depletion region. This is because an electron jump from valence band to conduction band after absorbing the photon, thus creating a hole in the valence band. Due to junction electric field, what is junction electric field? This is the junction electric field. This is reverse biased. P is P terminal. P end of the PN junction is connected to negative side of the battery and positive side of the battery is connected to N side. As a result, the junction electric field increases in reverse biased condition, due to which majority charge carrier cannot cross the junction, but minority charge carrier can move in. When the whole electron pairs are created, the newly generated electrons are moving towards the N side and newly generated holes are moving towards the P side. Because hole is positive charge always moves along the direction of electric field, and electrons are moving opposite to the direction of electric field. Due to the junction field, electron get collected on the N side and hole to the P side, thus setting up an EMF. This send a current through the load. As the intensity of radiation increases, more and more whole electron pairs are created, which increases the reverse bias current. That means if the intensity of the incident light increases, what is intensity? Intensity increases means more photon falls on the junction. If the more photon falls on the junction, more whole electron pairs are created, therefore strength of the reverse bias current through the junction increases. That is why we get the VI characteristics like this. As the intensity increases, the reverse current gradually increases. Another question may come, why the photodiode is always operated on the reverse bias condition? Why photodiode is operated on the reverse bias condition? So let us consider N type of the crystal. Let us consider N type of the crystal. That means N semiconductor of the crystal. We know that in N semiconductor, majority charge carrier are electrons, and let N be the number of electrons per unit volume of that particular crystal. And P holes are the minority charge carriers, let P is the number of holes. Let us consider N type of the crystal. Here majority charge carrier are electrons and minority charge carriers are holes. Let N represents number of free electrons per unit volume on the N type of the crystal, and P represents number of holes per unit volume of the N type of crystal. Since it is N type crystal, number of electrons is more than number of holes. Now when the light falls on the junction, equal number of hole electron pairs are created. That means newly generated hole and electrons are delta P and delta N. When light falls on the junction, equal number of hole electron pairs are created as the electron jump from valence band to conduction band. So what is the newly generated number of free electrons? Let it delta N. What is the newly generated number of holes? It is delta P. So therefore what is the total number of, what is the final number of electrons? It is N plus delta N. What is the final number of holes? It is P plus delta P. Since N is very, very greater than P, therefore delta N by N is very, very less than delta P by P. N very, very greater than P. So you just see N is in the denominator, P is in the denominator. Therefore delta N by N is very, very less than delta P by P. That means due to presence of light, the fractional increase of minority charge carrier on N side of the crystal is much larger than the fractional increase of majority charge carrier when the light falls on the junction. Similarly, the fractional increase in minority charge carrier, that is holes on the P type of the crystal, that is the fractional increase in minority charge carrier holes on the N side of the crystal, it's much larger than the fractional increase in majority charge carrier electrons on N side of the crystal. Similarly, on the P side, fractional increase in minority charge carrier electrons is much higher than the fractional increase in majority charge carrier holes on the P side of the crystal. As a result, fractional change due to photo effect on the minority carrier dominated reverse bias current is more easily measurable than the fractional change in majority carrier dominated forward biased current. তার মানে আমি কি দেখিয়েছিলো যে মাইনরিটি চার্জ কেৰিয়াৰৰ নাম্বাৰটো বেছিকে চেঞ্জ হৈছে, সেইকাৰণে ৰিভাৰ্স বায়াস কাৰেণ্টটো আমি ইজিলি কি কৰিব পাৰিম, আমি অবজাৰ্ভ কৰিব পাৰিম। দ্য চেঞ্জ ইন ৰিভাৰ্স বায়াস কাৰেণ্টটো ইজিলি অবজাৰ্ভ কৰিব পাৰিম। কিন্তু মেজৰিটি যদি মই ফৰৱাৰ্ড বায়াস কৰিলোহেঁতেন তেতিয়া কি হ'লহেঁতেন, মেজৰিটি চাৰ্জ কেৰিয়াৰ গ'লহেঁতেন। বাট fractional increase in majority surge carrier is very less. So therefore, the increase in current due to presence of light cannot be detected in the majority carrier forward bias current. That is why it is said that the fractional change due to photo effect on the minority carrier dominated reverse bias current is more easily measurable than the fractional change in majority carrier dominated forward bias current, and hence a photodiode is connected in the reverse bias. Okay? So let us consider N type of the crystal. I will repeat N type of the semiconductor. N is the free electron density, which is majority surge carriers, and P is the number of holes per unit volume. Since it is the N type of the crystal, N is very greater than P. N is very greater than P. Now, when the light falls on the junction, equal number of hole electron pairs are created. So, what is the final number of electron? It is N plus delta N. What is the final number of holes? P plus delta P. Since N is very greater than P, delta N by N very less than delta P by P. That means fractional increase in minority surge carrier, is much higher than the fractional increase in majority surge carrier, because initially N is very large and P is very small in N type of the crystals. So similarly, in the P type of the crystal, in the P type of the semiconductor, what happens? Delta N by N is very greater than delta P by P, because in P type of semiconductor, N is much smaller than the P. Number of electron is much smaller than the number of holes on the P side of the crystal. That is why the fractional change due to photo effect on majority carrier dominated reverse bias current is more easily measurable than the fractional change in majority carrier dominated forward bias current. Hence, a photodiode is connected in reverse bias. What are the uses? Photodiode is used in the detection of optical signal, in the demodulation of optical signal, in the light operated switches. তোমালোকে দেখিছা কিছুমান আমি যেতিয়া শপিং মলত যাও, মানুহজন আহিলে দরজাখন নিজে খুলি যায়, তো তাত তোমাৰ কি থাকে? আসলে ফটোডায়োড অপারেটেড সুইচ থাকে। তোমালোকে আৰু কিছুমান দেখিছা, কিছুমান স্ট্রিট লাইটত গুৱাহাটীতো আজিকালি আছে, যেতিয়া সূৰ্যৰ পোহৰটো পৰে ইন প্ৰেজেন্স অফ সানলাইট, যে তোমাৰ কি হয়, লাইটবিলাক নিজে বন্ধ হৈ যায়, আৰু ৰাতি হোৱাৰ লগে তোমাৰ কি হয়, স্ট্রিট লাইটবিলাক অন হৈ যায়। যে সেই সুইচবিলাকত তাত তোমাৰ কি কৰা হয়, লাইট অপারেটেড সুইচ ইউজ কৰে। In the speed reading of computer punch card actually paisa in the first and second generation of computers, to take the input data lobor karone punch card use korisil, he punch card bilak read koribor karoneo they use the photodiode. In electronic counters also, the photodiodes are used.